How to measure loudspeaker impedance, current and power using only a voltmeter. Suppose you had only a voltmeter and wanted to measure a loudspeaker. You can easily measure the voltage across the speakers shown in the diagram. But is there any way to measure other parameters such as impedance, current and power? You can, but you need an extra component. Find a power resistor, denoted with lowercase r on the diagram, and wire it in series with the speaker. Power the circuit with a constant frequency, for example 100 Hz. Also, for this measurement you don't need full power, you can supply moderate power to avoid the resistor overheating. Start by measuring the DC resistance of the resistor. This is actually done off the circuit. Next, measure the voltage drop across the resistor, shown here as V1. Avoid using long wires that add extra resistance to the circuit. Next, calculate the current through the resistor by dividing the voltage by the DC resistance. Because the resistor and the speaker are wired in series, the current flowing through them is the same. Next, measure the voltage drop across the speaker, shown here as V2. You can now calculate the impedance by dividing the speaker voltage drop by the current. There's one last measurement. Remove the resistor from the circuit and leave the speaker only. Power the circuit using the same frequency as before, but this time supply full power. Measure the voltage drop across the speaker. Calculate the current for this circuit by dividing the voltage drop by the impedance from the previous diagram. Finally, you can also calculate the power by multiplying the current by the voltage drop. In summary, you need to take 3 separate voltage measurements plus the DC resistance in order to calculate impedance, current and power. A demonstration follows. Bear in mind that this measurement is taken at 100 Hz. Measurement will vary depending on the frequency. To have a better idea of the electrical performance, you can take measurement at different frequencies as shown on the next diagram. As you can see, the blue plot shows the expected bell-shaped curve for the impedance. It seems that the free air resonance frequency of this driver is around 81 Hz. Also bear in mind that these measurements are RMS and not peak. The measurements shown here were not done at full power to avoid damage to the driver. For full power measurement of the driver installed in an enclosure. Thank you for watching. Enjoy.